So let me write everything afresh here and what is the annuity is going to be for n years and the amount that we are depositing every year is A. So what will be the sum of the annuity? So we write Sn, this will be equal to A 1 plus R is the rate of interest that we have told you, plus A 1 plus R n minus 2 plus A 1 plus R n minus 3, and likewise we go here and we write plus A 1 plus R and the last item is A. The last term is A. So just before this last year, that is last year is the nth year. When we will deposit this money at the end of this nth year, we will not get any interest. So what we do that we make a change here, we multiply it by 1 plus R. This one we are multiplying by 1 plus R. So all the terms will be multiplied by 1 plus R. The first term is multiplied by 1 plus R. So this will become 1 plus R raised to the power n, and this will become A 1 plus R raised to the power n minus 1. And this one become A 1 plus R raised to the power n minus 2. And likewise this will go, and this one, the item just before the last item, that is last term, will be 1 plus R raised to the power 2. And this last one will be 1 plus R. So in every item or every term is multiplied by 1 plus R. Now what you will do that you will take the difference between the two. So we'll write here Sn 1 plus R minus Sn, the difference between the two, this one and this one. So Sn 1 plus R minus n, if you remember, then this item is not here, this term is not here, so we'll have here 1 plus R raised to the power n. Then all the terms starting from here up to here will get cancelled out, and this term will remain. So we'll have minus A. When carry out the subtraction here, what you will have Sn R. Because if you remove the bracket, then you will see that Sn and Sn will get cancelled and you will have SnR. And here you will have A in the bracket 1 plus R minus 1. This is what we will have. Now what will be this Sn? This we can write here Sn, that is the sum of the annuity, will be A 1 plus R raised to the power n minus 1 divided by R. This is the how we can calculate the sum of an annuity. Now here this is the annuity, A is the annuity, and this one is known as annuity factor. And if we multiply the annuity factor by the annuity, we will get the sum of an annuity. So instead of writing this long expression, we can use this formula, simple formula, to find out the sum of an annuity. So now we have told you how to find out the sum of an annuity and also how to find out the future value of a single deposit which grows at compound interest rate. This is 1 plus R raised to power t. That is for t years. If here again, in this case, in place of n, if suppose the years are expressed as t, then we can also write here t. If you want, you can also write here t. And if you write t here, this will become like this. Because in this one, we have it shows the years by n, but here if you show the years by t, then in this case, this will become 1 plus r raised to power t minus 1 divided by r. So notation has been changed. So in order to show the similarity between the two, we have replaced the n here by the t. This n we have t, that is t years. It is being deposited for t years. So now we come to know that we have talked about the how to find out the future value of an annuity and how to find out the future value of a single deposit which grows at compound interest rate. Now we'll talk about how to find out the present value. If we take an example, suppose we have rupees 100 is being deposited now, and this rupees 100, the rate of interest is suppose 10%. Rate of interest is 10%. Then after 1 year, this amount will become 110. And after 2 years, this is after 1 year. And this is after 2 years. After 2 years, again 10% interest you will get on this 110, so it will become 121. So this we can say that 100 rupees grow and it become 121. How it grows? It grows at the rate of 10% and the interest here is compounded. That is, for the calculation of interest for the second year, the principal amount, that is 100, and the interest of rupees 10 both are added, and then interest is calculated on 110. So it is growing at compound interest rate and becoming from 100 to 121. Now if we find out the present value of this, that is the present value of 121, the present value of 121 is 100, because present time we have 100 and this 100 is growing and after 2 years it is becoming 121. So this 121, if you find its present value, it will become 100. Now what we have to do, that 121 has to be reduced. At what rate it should be reduced? The rate at which we have increased it, that is the rate of 10%. So here we have to reduce this. This method of reduction is known as discounting. This is what we call as discounting. Must be knowing discounting. Discounting means selling something at a price lower than its face price. So this is the value 121, so we'll discount. When you will discount at the rate of 10%, then after 1 year, that is in the second year, this one, it will become 110. Then in the present time, it will become 100. So I'll discount 121 by 10%, it will become 110. And again, discount is 110 by 10%, it will become 100. So this method is known as discounting, and the rate at which this reduction is taking place, that we call as discount rate. So there is a similarity, there is a link between the calculation of the future amount and from the future amount, how finding this present value. So the present value and future value are linked, and the link is through this rate of interest, that is 10%, and it is growing at the rate of 10%, 100 rupees becoming 121. Now if you want to find out the present value of this 121, we have to reduce it at the rate of 10% and it will become 100. So how to find out we have already told you how to find out the future value if you are depositing, if you are making a single deposit, or if suppose equal deposit we are making at the end of each year, that is sum of annuity. Now, how to find out the present value? What will be the formula? The formula we can obtain from this one. That is, this will help you to find out the a formula for calculation of present value. How to do that? I'll write it here. We have told you that Pt is equal to P0 1 plus R raised to the power t. Pt is the amount that you will get after t year. P0 is the initial deposit, that is the principal amount that we are depositing. R is the rate of interest, t is the number of years here. So we can find the P0. P0 is the present value. This is our P0 here if you want to know. And this is our PT. PT means P2, that is amount after 2 years. So this is the future value, this is the present value, this is the future value, this is the present value. So we want to find present value. So it will be PT divided by 1 plus R raised to the power t. This is the general formula for finding out the present value. If you are given the future value and the rate of discount or rate of interest is R and number of years are T, you can find out the present value. So in this case, if you want to find out the present value, and the present value here will be P0 and you are given P2, that is 121, and 121 1 plus 0.10 raised to the power 2. So this, using this we can find out P0, and P0 here will be 100. So using this formula we can find out the future value given the present value given the future value. That is, if you are given the future value, we can find the present value. Now we'll tell you that how to find out the present value in case of annuity. But before that, I have to remove it. So now we'll tell you how to find out the present value of an annuity. So here the annuity is being received for t years. Now we'll write t rather n, and the annuity is A that is being received for t years. So we can write it like this. Suppose it is 0 to 1, 1 to 2, 2 to 3, 3 to 4, and likewise the here. So this annuity 100, 100 or 100, or better we write A because then not be asked to replace it. So we write that A, 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 and at the end of 10th year, A. So we have to find this amount is being deposited at the end of the first year. So we have to find out its present value. It will be discounted only for 1 year. This amount is deposited at the end of second year. So it will be deposited for 2 years. It will be discounted for 2 years. That is this one and this one. This amount is deposited at the end of third year. So it will be discounted for 3 years. And this one is deposited at the end of fourth year. So it will be discounted, for 4 years, and this amount is deposited at the end of 10th year. So it will be discounted for 10th years. So we can find out the present value of the annuity, and let us write it as PV. PV is the present value of the annuity. Present value of the annuity we can write, it will be A 1 plus R. This is discounted for 1 year. this will be discounted for 2 years. The formula is same that we just told you. Let me write the formula so that you don't get confused. The formula is very simple. That is P0 that we just wrote you. It is PT divided by 1 plus R raised to the power T. This is the formula that we are using for calculating the present value. So present value of this for 1 year only. So we in the T takes the value 1. In this case, here we'll write A 1 plus R raised to the power 2, and here A 1 plus R raised to the power 3, and likewise we'll not write this one and go to the last one, that is A 1 plus R raised to the power T. So this last one is discounted for T years, and this one is discounted for 3 years. This is discounted for 4th year. We have not written here because of lack of space. That doesn't make any difference. This is the present value. We can write it like this if you want. We can write it A 1 plus R minus 1. We can write A 1 plus R minus 2 plus A 1 plus R raised to power minus 3. And likewise the last one, A 1 plus R minus T. Minus T. So same thing we have written in this way. There is no difference between the two. Now we multiply this one by 1 plus R. So PR, PV is multiplied by 1 plus R. So all the terms will be multiplied by 1 plus R. When the first term is multiplied by 1 plus R, this will become A, because 1 plus R minus 1 plus R, it will become A. And this one, A 1 plus R minus 1. This one will become A 1 plus R minus 2. Likewise, this last term, that is A 1 plus R minus T minus 1. We put it in bracket. T minus 1, because all the terms are multiplied by 1 plus R. So we take the difference between these two. So what we do, PV 1 plus R minus PV. You see, starting from here, all the terms up to this one get cancelled. This is minus T, this is minus T minus 1. That is one term before that. So we'll have here, if you take the difference between the two, it will be A minus A 1 plus R minus T. All other terms you will know will get cancelled starting from here, A 1 plus R raised to the power minus 1. This is from here up to here, T minus 1. T minus 1 is the term just before this term. It is minus T, it is just before that T minus 1. So this term will remain that we have written here. So we can write it as PVR, because if you take the difference, this is what we will have, and this will be A 1 minus 1 plus R raised to the power minus T. This is what we will have. So if you take R on the other side, then this can be written as PV. PV will be equal to A, and then in the bracket we will have 1 minus 1 plus r minus t, and this one r we take, suppose we write it here, can write anywhere. So let me write it here. The present value is a, right, take this one we can write as 1 minus 1 upon 1 plus r raised to the power t, and this is r. So this will be the present value, and this is how we can calculate the present value of an annuity. Present value of an annuity can be calculated by this simple formula, that instead of writing this entire expression, we can use this formula to calculate the present value of an annuity. Now, if suppose we want to know that, if suppose we have taken a loan and we want to know how much amount we should deposit every year so that the entire loan is paid. Suppose the loan amount is denoted by L. This is the L. L is the amount of loan that we have taken, and we have taken this loan for T years. And we want to know what is the annuity, how much amount we should deposit every year A, and how long this deposit should be carried out so that the loan amount become same as the total value of this annuity. So this loan that we have taken here and the annuity, that is the sum of the annuity, both should be same. And if this is so, we have just told you that this loan amount will be L 1 plus r raised to the power t. This is the loan amount. And the sum of the annuity, not the present value, the sum of the annuity, that is ST. These two should be same, so that the annual deposit that you will make should be that which help you to pay this entire loan. And by equating this, you can easily find out the annuity, the amount that we should deposit every year by, and so that the entire loan is paid. Now this annuity here, in the sum of the annuity for T years, we have not used T, we have used it as N, but that doesn't make any difference. We have using it T here. Sum of annuity over T years, and this, the loan that we have taken for T years, these two should be same. So this is an exercise that you can do and find out the annuity, that is what amount I should deposit so that this entire loan is being paid. Thank you very much.